Hey people, we meet again this time with chapter 5. So as you know, chapter 5 is a very important chapter in your exam, 20 marks. Quite a lot of things to be covered, but then worry not, I'm here to assist you. So if you are ready, shall we go and uncover what's in chapter 5? Mr. Raj, your mathematician. Are you ready people? Let's go. Here as a recap for chapter 5. We start off by talking about vertical line test and horizontal line test. Vertical line test is for you to know whether something is a function or not. Horizontal line test is to determine whether it is a one-to-one property. Let us go with our recap. So as you can see here, vertical line test. We use vertical line test as mentioned to check whether something is a function or not. So the criteria to be function is it must either be a one-to-one function or many-to-one relation only. So let us see how to determine whether it is a function or not. So as you can see here, okay, you got a cubic graph. Okay, you got a cubic graph here. So let me take the laser point and point to you, so easy for you to see. So as we draw a vertical line like this, okay, you can see it cuts, okay, only once. So if you do at any other place also, okay, you will only cut once. So meaning to say, you will see for any value of x, you get a value of y. For another different value of x, you get another different value of y. This means it is a one-to-one relationship. Hence, it is a function. In what scenario you're going to get not a function? Let us see. For example here, okay, as you can see, okay, I have a graph like this. So if you go and draw a straight line, which is a vertical line, okay, because we're going to do vertical line test, you can see it cuts at two places. So this means that for this value of x, I got a value of y. Then as I see, for the same value of x, I got another value of y. So meaning to say, this value of x go to a and also this value of x go to b. So this is actually a one-to-many relation. One-to-many relation is not a function. So by vertical line test, we can say this is not a function. Hope you are clear up until there. Okay, right. So now we have reached, okay, this is like the very popular one. We want to check the one-to-one property. So here you go. We got two kind of tests for us to do. So you might be wondering, okay, is it okay for me to just know one? No, you need to know both. Why? Because sometimes the question can specifically tell you by using horizontal line test, check whether the function is one-to-one. Or by using algebraic approach, by using algebraic method, check whether the function is one-to-one. So because of that reason, you need to know both. So let us see horizontal line test. So in order to know horizontal line test, you need to be very good with your graph sketching. So in case you have forgotten how to sketch graph, please go and revisit some of the videos that I've posted in my channel. So here you go, a very simple question. So the question is, we are given a quadratic, okay, we are given a quadratic here, x squared plus 3. So we want to check whether it is one-to-one relation using graphical method, and also we want to use algebraic approach, okay, to see whether it's one-to-one or not. So I've plotted, okay, the quadratic. Well, it's not difficult actually to draw quadratic. Happy graph cuts at 3. So now what I'm going to do is I'm going to go and draw my horizontal line, which is that horizontal line. You can clearly see that it cuts at 2 places. What's the big issue cutting at 2 places? Well, if you see, this value of x is going to go to value of y, and this value of x also going to go to the same value of y. So what does that mean? This means that it is many-to-one relation, hence not one-to-one. Okay, so it cuts the curve twice. So it is many-to-one relation, it's not one-to-one. So there you go. By horizontal line test, we have proved that this is not a one-to-one relation. Let us see using algebraic method. So algebraic method is the one that students always have problem. So let us see. So here is some tips that I would like to share with you. So basically, if you don't know how to do algebraic method, no problem. What you have to do is you just start with FA equal to FB. If you manage to just get A equal to B, that means it's done. It is one-to-one. No need to worry anything. If you get anything extra, then it is safe to conclude that it's not one-to-one. We're going to use the same function, the quadratic function, and we're going to prove that it's not one-to-one as what we saw in the horizontal line test. Hope you can follow up until here. Let us proceed. All right, so here you see, okay, so normally what I tend to do is I tend to write on the board. So this time around, okay, got everything nice here. So I'll just explain to you the steps. So as you can see here, this is our function. So you know FA just substitute, FB just substitute. So get this. Just a method of simplifying. So simplifying means get rid of the 3. I don't want the square, so I go and square root. So when you square root your b square, obviously you know by definition it is modulus. So technically you are getting a equal to b and a equal to. So as I mentioned to you earlier, if you get anything extra, okay, that means it is safe to conclude it is not a one-to-one relation. So that is what we are going to do here. We conclude by saying it is not a one-to-one relation. All right, so we know our quadratic, okay, that we have just now, okay, is not a one-to-one relation. So basically, in order for inverse to exist, one-to-one is an important property. So here we know quadratic, okay, by horizontal line test, it's not one-to-one. So the question is, right, can we force inverse? Yes, we can. Okay, how do we do that? We restrict the domain. So here you need to go and recall, okay, what is the meaning of domain? So domain here is the value of x where the graph exists. So as you can see here, this is the place where, okay, the curve exists. So our domain is negative infinity. So what we can do is we can restrict our domain. So restrict domain here means either I take this part of the graph or I take this part of the graph only. So when I do that, for instance, I take this part of the graph only, you can see, okay, this is what we got. So by horizontal line test, you can see we're only cutting once, meaning to say it is a one-to-one property. Similarly, if I take just this part of the graph, I'm going to just cut once. So that would mean a one-to-one property as well. So there you go. So it doesn't matter if at the start of the question, okay, you see it's not a one-to-one relation. What we can do is we can force the existence of inverse. How? By restricting the domain. Okay, people. So once we have, we know that the inverse exists. What we are, the question normally asks us to do next is to find the inverse function. So to find the inverse function, there is two methods. One is the method of mapping that you have already studied during your advanced days. Personally, this is like my favorite. But then there is few word of caution that I'd like to ask you to do, whereby please first of all draw out this mapping. Okay, so whereby you got x, you got y. So f will bring x to y will be brought to x by f inverse. So make sure you write down this statement very clearly. Okay, this statement very clearly and write this statement. We know that, so that nobody can question that you are doing this, okay, based on assumption. Okay, that is one. So once you got that, okay, I can go and do, okay, the inverse function using these two information. So how do we do that? So here domain already defined, meaning to say I only take the part of x greater than equal to 0. So the first information is when I see fx, I'm going to go and replace with y lah. Okay, so I'm going to do that. So once I do that, I'm going to go and get expression for x sama dengan kenapa. Why do I want that? Okay, because you can see here, the second information is x equal to ma. So I go and get x equal to. Of course, here you get plus minus, but then based on the domain, this guy is not here for decoration. You choose the positive. So I get that. Okay, use the second information. Remember this one, this y you can simply replace, meaning to say I put 1, here's a 1, put 2, here's a put 2, here I put 3, here's a put 3, here I put x, here's a put x, hence I get the inverse function. So this is using the mapping method, nice and easy.